Good morning, everybody. Welcome to a wonderful Monday morning, the first Monday of October, with your host, me, Dr. White, and Chem 1211. Boy, this year has gone. It's the beginning of October. By the way, summer is over. How do I know that? Because I have moved my short sleeve shirts to the back of my closet and moved my long sleeve shirts. Was there something on there? Well, it's off now. To my front of the closet. So it must be fall and winter. It is. All right. A couple important things. One, uh, one of your colleagues emailed me over the weekend, trouble they were having with the balance with the lab we did last Tuesday, and forgot to tell you uh, that the balance limit you get with the kit is 100 grams. When you do the 3 rings, which I don't have with me right now, you do the 3 rings, not in a cup or anything else, because if you do it in other things, you'll be over the limit. I think it goes L on the balance readout or something like that, OL. So make sure when you're doing the labs this semester, oh, blueberry tea, the best, except for my vanilla almond. Make sure when you're doing the labs this semester, you don't overload the balance. So if you're supposed to do 3 rings or whatever, just weigh what they tell you to weigh on the balance. All right, that's number one. Number two thing I want to talk about is, as you know, I had to change because department rules changed how I give quizzes and tests. And when I normally in the past taught 1211 or its equivalent 112 at LG Community College, which I've done once, twice, a lot of times, the test that's coming up, which is historically in the past called test 2, but now it's called test 1. I like special effects. But anyways, test coming up is historically the lowest average of all quizzes and tests. It's the lowest. That's because it's the hardest, but it doesn't have to be. I've had 12, 11 classes that have had very high averages on the upcoming test. But because the majority don't, I'm telling you this up front so you know to keep up with the practice problems. Study. More importantly, do the practice problems. Tomorrow in lab, I will be doing chapter 10. Oh, I'm glad I have 5 fingers on both hands. Chapter, uh-oh, it's Bad Humor Monday. That was pretty bad. But anyways, I will be doing chapter 10, part 2. Make sure you do it before I do. Also, let me remind you that my office hours, as I mentioned last week, are now Tuesday and Wednesday from 6 p.m. to 7:15 p.m. If you need special help, email me and I'll see if I can fit you in because we're on Zoom. So I don't, and you don't have to drive to COD. And the last thing I want to talk about is tomorrow, I guess it's this way, tomorrow's lab. And tomorrow's lab is a Dr. White lab. Historically, when you teach Chem 1211, there are 14 labs. But because we're using a kit and a new one, we're only able to get the full-time faculty 12 labs out of the kit. So I've included 2 labs of my own. Now the lab we'll do tomorrow, I like special effects. Tomorrow, well, looks like I've been practicing. Anyways, you will not use anything out of the kit. You won't have to mix any chemicals. It's more mental exercise, but I think you'll enjoy it. All right. With that, before I start, are there any questions? Remember, in my world, there's no such thing as a dumb question. Look at the chat. Nope. All right, let's get going. All right, last week I want to go back and review something that's very important, one of the most important concepts in all of chemistry, and that's the mole. And the concept I want to review and the question is, by the way, thumbs up, people. Everybody see my whiteboard, 8 points? Thank you, everybody. All right. So I'm going to have you help me out. And what's the first thing you should put there? What are you being asked to find? What are you given? Your turn. Wow, we got a full house today. And when you figure that out, give me a thumbs up. I'm only asking you to figure out what are you being asked to find and what are you given. When you're done that, give me a thumbs up or any other emoji you want to use. See how nice I am? I give you a choice. All right, looks like the thumbs up are coming in. And I think everybody's done. What are you being asked to find? And I like to put a question mark to let me know that's what I'm being asked to find. You can use whatever. How many moles of hydrochloric acid? HCl is hydrochloric acid. I want to ask that on test. Later in the semester, I'll teach you what is an acid. But for now, I should say one of the great miracles of life in my mind is the fact that you and I have cells in our stomach that produce hydrochloric acid, HCl. All right, back to the problem. We're trying to find how many moles of HCl. We're given 3.789 times 10 to the 5th grams of HCl. So how do we proceed? Well, first of all, once you've done this, you no longer have to look at the word problem because everything you need is right here. All right, the only thing we have to start with is this number. What units do we want our answer in? Your turn. I'll give you 15 seconds. Go. Four, three, two, one. I'll give you a bonus extra 6 seconds. All right. What are we being asked to find? Well, we took the time to figure that out, and that is moles of hydrochloric acid. Now, if there was a conversion factor, a ratio, what would go on top of this ratio? What would go underneath? This the units, no numbers, this the units. Your turn. When you're done, give me a thumbs up. Thank you, Anna. And thank you, Gianna. There are actually two Giannas. We've got Gianna squared today. We got Dr. White too. All right, let's do it. And now it's time for your good buddy, your good friend, unit analysis. And for many, I hate to say this, decades, it's been my good friend, my good buddy. How does it work? Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of, unit-wise, goes underneath. And now I'll write it in. And now we have the units. But where do we get the numbers here? Well, where can I find a relationship between moles of a compound, that's what HCl is, and grams of a compound? Well, and I don't think I had a chance to change it yet. It's bad, Dr. White. Hopefully this week I will. If you go to important information, now labeled test 2, but I'll be labeling it test 1. Notice right here, 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights in that compound. And the past students would have to memorize this, but this will be given to you on the new test number 1. So let's use it. Remember, A equals B. You have 2 ratios. So 1 mole of a compound, 1 mole, in this case HCl, equals the molecular weight, that's what MW, in grams of HCl. It looks like a whole word, so I'm going to erase this and do this. So, oh no, we need the molecular weight of HCl. And the molecular weight is the sum of all atomic weights in a molecule. Well, in HCl, hydrochloric acid, we have 1 hydrogen and 1 chlorine. And let me remind you, on test number 1, underneath their name, it will say in bold letters, please use proper significant figures for all calculated answers, and please use all atomic weights to 3 significant figures. Well, how do we do that? Well, we go to our friendly neighborhood periodic table. This is the periodic table you will be given when you take test number 1. Remember, test number 1, I think it's coming up in 2 weeks, not this week or next week, but the following week. You'll have from Monday through Thursday to take it at the test center. And when you do, you'll be given this periodic table along with your test. And if we look at hydrogen, the atomic weight underneath the symbol is 1.008. The 3 significant figures, keep the 1, keep the 0, keep the 0. 8 is 5 or higher. So you drop that, increase the number in front by 1.01. Now, chlorine, a halogen, all the way over here, is 35.453. I'm going to give you some fun, let you have fun, round that off to 3, yes, 3 significant figures. Notice I use my left hand a lot. I'm ambidextrous. While you're doing that, I'm going to have some more tea. Oh, is that good? Ooh. All right, let's round this off to 3 significant figures. Keep the 3, keep the 5, keep the 4. Those are my 3 significant figures. Use the next number to round off. That's 5. Ooh, that's 5 or higher. Duh. And yes, I watch The Simpsons sometimes, not as much as I used to. But anyways, you drop the 5 and the 3, increase to 0.4 by 1, 35.5. So now we know the 3 significant figures. This is 1.01. There's only one of them. There's only one chlorine. So that's 35.5. I added up. Now you get 36.51. Now, when you do addition, you have the same number of significant figures. Ooh, there was a piece of dirt on my tablet. Let's try this again. Dirt's gone. All right, you have the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. This has 2, 0, anything after the decimal is significant, 0 and 1, 2. This has only 5, so that's 1. What's the lower number? Hopefully you pick 1. So now we have to round 36.51 to one significant figure past the decimal point. Keep the 1, 5. Yeah, I got ahead of myself. Keep the 5. Use the 1 to round off. Is that 4? Or yes, yes. So the correct answer is 36.5. And now we know from this and this, 1 mole of HCl is equal to the molecular weight, 36.5 grams. Now, before I pick up my calculator, oh, I did, better put it down, bad not going. It is Bad Humor Monday. Notice grams of HCl divided by grams of HCl. Anything divided by itself equals the number 1, meaning it's gone. So this cancels out. I'm left with moles of HCl, which is what I want to get. So now I can pick up my calculator, turn it on, clear it, 3.789. Then for this calculator, second key, then double E above, and you'll see a little E on your screen. And now I want 5, and then I'm going to divide it by 36.5. And my calculator throws me this huge number. Let me make a little room right here. This right here. But remember on test 1, like all my quizzes and tests, it will say, please use proper significant figures for all calculated answers. Look out, I'm going to go Technicolor on you. And if we look at this number right here, it's got 1, 2, 3, 4, 4 significant figures. This number has 1, 2, 3 significant figures. The 1 is part of this definition. Therefore, it's an exact number, plays no role in the determining significant figures. And when you multiply and divide, which is what we're doing, you get the same number of significant figures in your answer as the number that has the lowest significant figures. So now we got to do some tough math. Which is smaller, 4 or 3? And time's up. Hopefully you pick 3. Now your turn, then I'll do it. Round 1.0380819 times 10 to the 4th, the 3 significant figures. Now I'm gonna have some more tea. When you're done, give me a thumbs up. I'm looking over here where the videos are, so I can look for a thumbs up. or any other emoji you want to use. I got a clock over here with seconds so I can time you people. All right, time's up. Thank you, Gianna. All right, how do you round this off to three significant figures? Keep the 1, keep the 0, keep the 3. Those are my 3. Use the 8 to round off. Is that 4 or less or 5 or higher? Hope you all pick 5 or higher. I'm going to drop all this and increase this by 1. How many of you like this blue color? Actually, cyan, I believe. Well, nobody does. All right. But anyways, let's go back to black. And the correct answer is 1.0, and I increase the 3 by 1, 4 times 10 to the 4th grams, or wait, moles of HCl. You don't have to put on the units. And this is my answer. And that's how you do this. You should know how to do this. Oh, let me be subtle. Is that subtle? Know this. All right. Let's continue on. I wanted to go back, and I do that throughout the semester, and you've already seen me do that. Let's go back to where we left off last week. And by the way, I'd like to thank all of you for making Dr. White a YouTube star. And if anybody else who's out, not in my Chem 1211 course, but in other ones, email me at whitek@cod.edu, white, WHITEK, @cod.edu, and let me know how you like what I'm doing. All right, we're talking about the chemical equation, and a chemical equation allows you to see a chemical reaction in a convenient way. And the reactants are always on the left of the arrow. I'll show you this in a second. The correct formula for the products, what you make, are always on the right side of the arrow. And the arrow always points toward the products. Plus signs are used to separate different reactants and products. So what does that mean? In general, let's get to the right color. A and B are the reactants. And I'll also say, because I come from the chemical industry, you'll hear me say later in the semester, starting materials. And you should know this, that A and B are your reactants or starting materials. At the base of the arrow, that's where you'll find your reactants. At the head of the arrow, let me clean this up. At the head of the arrow, you'll find the products, or there might be only one product. And C and D are the products of this reaction. And what this tells us is if you mix A and B together, that plus sign, think of the word and, you will make C and D. An important part of a chemical reaction is It's correct. It shows experimental results. If you did go into the lab and mix A and B, you will get C and D. Snuck in a tea break there. Now, because of conservation of mass, you never create or destroy atoms, period. There must be the same number of atoms of each type, kind of atom, element, or compound, or element, I should say, on both sides of a chemical equation. And this is called a balanced chemical equation. And it has the same number of atoms of each type of element involved. I don't know why there's a question mark there. There's no question in my mind about it. Oh, it's funny, it's Monday, sort of. But anyways, a balanced chemical equation has the same number of atoms of each element involved in the reaction of each side of the equation. And that's because of conservation of mass law. Now, when balancing a chemical equation, an unbalanced equation is brought into balance by adding, should be, correction on the fly, by adding coefficients, and I'll explain in a second what is a coefficient to the equation to adjust the number of reactant, product, or reactant or product molecules or elements present. And here's a note to Dr. White. Remember torsion balance or teeter-totter analogy. Ooh, big new word, analogy. All right, let's look at the following. And I did this last week, but this is good review. We look at this equation. Everybody see the equation? H2 plus O2 makes water, H2O, on your screen. Thumbs up, people. Thank you, Rochelle. Thank you, everybody. All right. Now, what this tells us is if you take hydrogen gas, oxygen gas, you'll make water. But notice here, I have 2 oxygen. Here, I only have 1. So it's not balanced. How do you balance it? You cannot change the formula of a molecule. No, you can't. Well, you can try, but it will be wrong. And don't. I see that on tests. Students try that, and it's never going to be right. What you can change, and I think I'm going to sneeze. Hold on. Wow, that was a slow motion sneeze. But anyways, back to chemistry. You can change the number in front, called the coefficient. And when there's no number, it's the number 1. And this is the coefficient. I spelled that right? Probably not. I always get coefficient spelled wrong. But anyways, well, if I have 2 oxygen here, how do I get 2 oxygens on this side? I change the coefficient in front of water to 2. So now I have 2 oxygen here, but 2 times 2, I have 4 hydrogen. Well, I only have 2 hydrogen on this side. How do I get 4 hydrogen there? I put the number 2. Now 2 times 2, because there are 2 hydrogens in each molecule of hydrogen gas. I have 2 of them. I have 4 hydrogens. So if I look at this, I have 4 hydrogen. I have 4 hydrogen, because 2 times 2 is 4. That's okay. It's balanced. I have 2 oxygen. I have 2 oxygen. It's balanced, and therefore this is a balanced chemical equation. And what it tells me now is to do this reaction, it takes 2 molecules of hydrogen reacting with 1 molecule of oxygen to make 2 molecules of water. Now, there's an important aspect of balanced chemical equations. You should look at the coefficients, and you should never be able to divide by a number, so each coefficient is a whole number. And let's take a look at this example. What if I'd done this? And if we look at this new equation, I have 8 hydrogen. Oh, I have 8 hydrogen. I have 4 oxygen, 2 times 2, 4, and 4 times 1 is 4 oxygen. And you could say, oh, that's balanced. And on a test, it would be wrong. Why? Because I can divide each of the coefficients by the same number and get a whole number. And what would that be? Well, if I divide each one by 2, divide 4 by 2, I would get this. This by 2, I'd get that. This by 2, I would get this. So whenever you can divide all the coefficients by a whole number and still get whole numbers, because coefficients are, oh, excuse me, are always, they're called exact numbers, which are whole numbers. You can't have 2.6 molecules of hydrogen gas, just like you can't go into the store and say, could I buy half an egg? Don't try that, please. You can't, because you can only buy whole eggs because they're exact numbers. There's things. All right, so this is how you balance chemical equation. Remember, all atoms on each side, you have to have the same number and the same type of atoms on each side, which in the top equation, 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. Now, balancing chemical equations is one of the most important principles in my mind in chemistry. And therefore, on test number 1, I'll either have out of 100 points, 9 or 12 points. They'll each be 3 points each. There'll be 3 or 4 balanced chemical equation problems. Now, listen carefully. If I ask you to balance an equation, you're going to have to. If you put down the answer, it's already balanced, that will always be wrong on my test. The ACS, it's a different thing. Why? Because Dr. White teaches by his golden rule of teaching, which means I don't do to my students what I didn't like to be done to me when I was a student. Yes, in a galaxy far, far away, long ago, I was a student. And if I had on a test like balance equation, and the answer was already balanced, that's not fair. You want me to balance equation, have me balance equation. So I will. So let's get back to other important things on how to balance an equation. Again, the coefficient, oh, I spelled it right. Yay. But anyways, that's the number in front. Now, I thought I had a slide, I don't, so I'll go through it now. Now, the following are certain tips from me, Dr. White. And let's look at a reaction we have to balance. Everybody sees C3H8 on your screen? Thank you. And sometime in the future, like in a couple of weeks, you see on a piece of paper you're taking at the test center, 3 points each, balance the following chemical equation. Or if I'm lazy, I'll just write balance the following, or I could have put chemical equation. And you say, how do I do this? And if you notice, I have 3 carbons here, 1 here. It's not balanced. Well, here's tip number 1 from Dr. White. Always leave hydrogen and oxygen last. It's I can't spell Monday. I can spell the word Monday. Now, these tips I'm giving you, I've been using for a long time. Let's face it, I've been balancing chemical equation a few more months than you have, a few more, many, many months, many years. I'm not going any further, but it's true. So let's look at this equation again. And you'll learn later on, this is called combustion. C3H8 is called propane. And that's the stuff, the material in the white tanks you buy for your barbecue. And this also makes heat. And this is how your barbecue cooks your food if you have a propane barbecue. Dr. White loves his barbecue. But anyways, how do you do that? Well, I'm going to follow Dr. White's tip. Why? Because I'm Dr. White. And I have 3 carbon here. How do I get 3 carbon on the head of the arrow, the product side? I put a 3 there. So now I have 3 carbons. And it's time to move on. Oh, there's only hydrogen and oxygen. So I'll left them for last. I'm going this way. So if we go next, hydrogen, because that's all we have left, hydrogen, oxygen, I have 8 hydrogen on this side. Oh no, I only have 2 here. How do I get that onto 8? No, you can't change that number, but you can put the coefficient 4. 4 times 2 is 8 hydrogen. Wow, that's looking good. And the only thing left we have is oxygen. And here I have 2, but how many oxygen on the product side? Well, you add all of them up. In CO2, 3 times 2 is 6 oxygen. In water, 4 times 1 is 4 oxygen. Add that together. On this side, I have 10 oxygen. Well, I only have 2 here. How do I get that to 10? I will put a 5 there. And now I have 5 times 2, 10 oxygen. Now, if you notice, I wrote that on the piece of paper, and I'd highly recommend you do that. Why? Because after taking tests for a long time as an undergrad, I found that the more I let the paper do my thinking, the better my test scores were. And this way you don't have to keep in your head, but it's on the paper. Now I can check. I have 3 carbon, 3 carbon. I have 8 hydrogen. I have 8 hydrogen. Ooh, looking good. And I have 10 oxygen 10 oxygen. Yay, this is balanced. And that's how you do it. And again, my first tip is leave hydrogen and oxygen last. So I better share the fun. So here's one for you to try. Hold on, let me change this. And by the way, this is called octane, and it's a major component of gasoline. You go to a gas station, you'll see the octane number, and I'll talk about it later in the semester, on the gas pump. And they're talking about the amount of octane in your gasoline, plus other stuff too, I'll mention. All right, your turn. Balance the following chemical equation. 3 points each. Your turn. Remember, leave hydrogen, oxygen last. You can do it first, but leaving it for last makes it a lot easier. Trust me, I'm a chemist. Does that work? How about trust me, I'm a doctor? Does that work? And when you're done, give me a thumbs up. Hold on, I made this too hard. This is a hard one. Let's do an easier one. I can,
Will we have the hard
no,
ones or easy ones on the test?
I will make them not impossible.
Okay, thanks.
Because that one I know how to do, but
Yeah, I got
a
stuck
lot
on the
more,
box
it's
again.
a lot more complex. And for this class, I won't give that. Let's do this one. This one's more typical of what I'll do on a test at your level. Now, the one I had up, yes, I can balance, but there's some, takes a little while. This is more straightforward, which is what I will do on my test. Remember, on test one, there'll be 3 or 4 of these type of problems. Remember, don't forget the hand in labs. I should play some game show music like they have on TV when the contestants have to write down their answer. You know, like dun dun dun. Never mind. When you're done, give me a thumbs up, please. Thank you, Rochelle. Remember, leave hydrogen oxygen last. That's my tip for right now. Remember, try these out on your own. I have a problem set with these. When I do it, it looks easy. When you try it at home or wherever, the first couple times, it's not that easy. It wasn't for me. All right, if I look at the clock, I better get going. So let's do this. If I notice here, I have no pen. Now I do 5 carbon. Oh no, I only have 1. You have to have the same number and same type. So how do I get the 5 carbon on this side? I put a 5 there. So now these are balanced. Now next, I'll go this way because I'm lazy, and I have 12 hydrogen. And this side, oh no, I only have 2 hydrogen. I need 12. How do I get that to 12? Well, I can't change this number, but I can change the coefficient. And 6 times 2 is 12 hydrogen. So that's balanced. And now I have 2 oxygen here, but how many oxygen on this side? You count all the oxygen atoms in all the molecules on the product side. In this case, I have 5 times 2 is 10 oxygen, plus 6 times 1, 6 oxygen. Add that together, keep an eye on me, make sure I don't make a mistake. I think I did that right. I have 16 oxygen. How do I get 16 oxygen on the reactant side? Well, I can't change the 2, but I can change the coefficient. 2 into 16, 8. 8 times 2 is 16 oxygen. And now I'll check again. I have 5 carbon, 5 carbon. I have 12 hydrogen, I have 12 hydrogen. And I have 16 oxygen. Wait, hold it. I have 16 oxygen. It's balanced. Yay. And as I look at the clock, it's time for a break. So let's take a 5-minute break. I'll be back in 5 minutes. I'm going to get up and stretch, and I'll see you in 5. See you in 5. I'm back. Hopefully you are too. All right, let's continue with balancing chemical equations. Remember, due to the conservation of mass law, in a chemical reaction, atoms are never created or destroyed, meaning you have the same number of atoms of each type on each side of the chemical equation. Base of the arrow, reactants, head of the arrow, products. And you should know that. So let's do another one. If you take sodium metal, Na, plus chlorine gas, Cl2, and mix them together, don't try this at home because it's very exothermic, gives off a lot of heat, a lot. Go to YouTube and you can find some neat videos of this being done. Now you know I'm a chemist. But anyways, you make sodium chloride table salt. Your turn, balance it, please. Please, pretty please. Hint. Oh no, there's no oxygen or hydrogen. So get to work. And give me a thumbs up when you're done. When I look like this, I'm looking to see if anybody's got their thumb up. And by the way, don't forget, this week is National Turn On Your Webcam Week for Dr. White. So if you'd like, turn on your webcam so I can see I'm having real people with me. You don't have to, but it would be nice. Make me happy. And when you're done, give me a thumbs up. Speaking about done, I'm empty. Well, move over to the water bottle. All right, I think everybody's done. So I'm going to get started and have fun too. I say fun enough times, you'll believe me, because it's true. Now, if I look at this, I have one sodium, I have one sodium. Looking, here I have two chlorine, but I only have one on this side. How do I get to two chlorine? I change the coefficient. You can't put a 2 there. Students try and do that, and that will always be wrong. So now I have 2 chlorine, and 2 chlorine. This is Cl. I don't know how to print Cl and make it look good to me. So that's the one cursive letters you'll have to learn. But now I have 2 times 1, 2 sodium. But on this side, I only have 1. How do I get to 2? Put a 2 in front. And now I have 2 sodium. And let's see if it's balanced. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Yay, it's balanced. Now, let's look at something a little more challenging, which will be the following. And I'll do this one, then I'll let you try one. So I'm going to follow my advice and leave hydrogen, oxygen last. You can do it first, but it makes it more challenging. In other words, more difficult. I have 1 aluminum here. Ooh, I have 2 aluminum here. How do I get this to 2? I put a 2 in front. So now I have 2 aluminum here and 2 aluminum there, Al aluminum. Hydrogen, now wait till last. Oh, I have 1 sulfur here, but here I have 1 sulfur. But notice it's inside the bracket, and the number right here outside the brackets is 3. So you multiply this times this, I have 3 sulfur. Well, if I only have 1 here, how do I get the 3? I change the coefficient. Now I have 3 sulfur. Well, I've done aluminum, I've done sulfur. All I have left are hydrogen, oxygen. So now I'll do those. How many hydrogen? 3 times 2. That's 6 hydrogen. Oh, I have no hydrogen here, but here I have 2, but I need 6. How do I get that to 6? I change the coefficient. 3 times 2, hopefully is 6. So now I have 6 hydrogen on both sides. And finally, how many oxygen? 3 times 4 is 12 oxygen. Remember, you multiply the coefficient times the number in the molecule. On this side, how many oxygen do I have? And did I write something wrong down here? I did. Dr. White made a mistake. Once in a while, I'll do that. That should be hydrogen. Sorry. Change that. I was looking at the wrong problem for that. I figure once in a while, and I check on the test, I do make a mistake like that. And now we'll do oxygen. I have 3 times 4. I have 4. Oops, didn't want to do that. I have 4 times 3, 12 oxygen. Again, this should be hydrogen, not water like I had it. I have water on the brain. Hold on. It's gone. All right. So let's check. Is this really balanced? I have 2 aluminum, 2 aluminum. I have 3 sulfur. Ooh, 3 sulfur. 3 times 2, 6 hydrogen. 3 times 2, 6 hydrogen. And 3 times 4, 12 oxygen. Ooh, and 3 times 4, or 4 times 3, 12 oxygen. It's balanced. And that's how you leave hydrogen and oxygen last. So I better let you have one. I better make sure I write this correctly. And here's one for you. As mercury, Hg is mercury hydroxide with phosphoric acid, H3PO4, makes mercury phosphate plus water. And while you're doing that, I think I'll take a walk around the block. Not. And while you're doing that, I'm going to look over my flashlight collection. By the way, the person who sent me a nice link, and I've got it right back, thank you, about a flashlight they saw at a big box store. Thank you. Quick personal timeout. Since I was a little kid, real little, I love flashlights. My father did too. And in the last couple of years, last year and a half, there's been an explosion of high-end, really amazing flashlights, which I've been collecting. And my favorite is this one right here. I can't turn it on. There are 9 white ones, and these are red. And this is, here, I'll show you something neat. You see it? Let's see. And now it's red. And now it's white. And this thing is really bright. By the way, this costs $125. Yeah, I like high-end flashlights. And plus it has these neat little LEDs that change color. But the person who sent me the link, thank you. Oh, I got to show off my flashlight, favorite one. All right, let's get to work. Question is, balance the following chemical equation, 3 points each. And how do we do that? Followed my advice, leave hydrogen and oxygen last. So I have 1 mercury Hg here. And over here, I have 3. So how do I get this side to 3? I'll put a 3 in front. Well, oxygen, hydrogen, Dr. White says leave that to last. So I'm going to follow my own advice. Hydrogen, ooh, a phosphorus, P. And here, how many on this side? Well, in the bracket, I have 1, the bracket, but the number outside the bracket is 2. So 1 times 2, 2 phosphorus. I only have 1 here. How do I get that to 2? Change the coefficient. Remember, you can't change the chemical formula. Students try. Guess what? It's always wrong, but I can change the coefficient. So now I have 2 phosphorus, 2 phosphorus. All I have left are hydrogen and oxygen. And why don't, since I'm going this way, I'll do oxygen. On the reactant side, the left, how many oxygens? Well, this is going to be a little tricky, not really. 3 times 2 is 6 times 1 inside. So that's 6 oxygen. But over here, I have 2 times 4, 8 oxygen. And that equals 14 if I did my math correctly. I have water on the brain. So I have 14 oxygen, 2 times 4 is 8, 3 times 2 is 6. How do I find out how many oxygen I have on this side? The product side. Well, here's an oxygen, 4, but times 2, that's 8 oxygen. Here I have only 1, but I need 14. Well, once you've done the coefficient of something that's non-hydrogen oxygen, you don't want to change this. But this one I can. Here's 1 oxygen. I want to get to 14. I already have 8. So I need 6 more. How do I do that? Put a 6 there. And that equals to 14 oxygen. So I've done my mercury, my phosphorus, my oxygen. The only thing left is hydrogen. On my reactant side, I have 3 times 2 times 1, 6 hydrogen. Over here, I have 3 times 2, 6 hydrogen. Add those up, and I get 12 hydrogen. On my product side, how many hydrogen? Well, the first molecule is 0. And the second one, 6 times 2. That's 12 hydrogen. I think I'm done. And because I took the time to draw it on the paper, write it down, I can do the following check, sort of like balancing your checkbook. It's 3 mercury, 3 mercury, 2 phosphorus, 2 phosphorus. Ooh, looking good. 14 oxygen, 14 oxygen, looking real good. 12 hydrogen, 12 hydrogens, it's balanced. And that's how you do it. Again, leave hydrogen, oxygen last, excuse me, and change the coefficients to bring everything in balance. And remember I said, remember to teeter-totter? How many of you have ever been on teeter-totter when you were little? You know how it goes like this? Ooh, I like those special effects. Now, if you have someone who's not the same weight, it goes like that or it goes like that. But when 2 children are the same weight, it will stay like this. Same thing with a chain balance, torsion balance, they're called. And if the weight of what you put on, the weight of what you're measuring is the same, they're the same, they're balanced. And that's where the name balanced chemical equation came from. Now, there's one more tip or trick I need to teach you. And that's called what I call the even odd. And let's look at a reaction. And here, if I take sulfur and oxygen, I'll make sulfur trioxide, SO3. Now, 1 sulfur on one side, 1 on the other. But here I have 2 oxygen, and here I have 3. There's no whole number. Remember, the coefficient, the number that goes in front, has to be a whole number. Can't be like 7.2 or a fraction. There's no whole number I can multiply 2 to get the 3. There's no whole number I can multiply 3 by to get to 2. So what do? Well, notice even, odd. When you have an even odd, here's the trick or the tip. What number does 2 and 3 both go into to give a whole number? And the answer is 6. So how do I get 6 oxygen on this side? Multiply that times 3. How do I get 6 oxygen on this side? Multiply that times 2, the coefficient. Now they're balanced. And on this side, how many sulfur? 2 sulfur. How many sulfur here? 1. How do I get that to 2? 2 sulfur. And that's the trick. Let's first make sure we're balanced. 2 sulfur, 2 sulfur, 6 oxygen, 6 oxygen. So what's the even odd? When you look at 2 or an element, and on one side you have an even number and the other you have an odd, then you say, what number do they both go into? Multiply the 2 together. 2 times 3 is 6, and you make the same number of atoms on both sides. And here's one for you to try. And the question is, balance the following chemical equation, 3 points each. Your turn. And don't forget, a lab is due tomorrow. When we're done, give me a thumbs up. Thank you, Gianna. One of the two. Oh no, we've got Gianna squared again, G squared. When I worked at one company, my first name, Kenneth, they were in the building I worked in, the research center. There were 3 Kenneths. That's the only time that's ever happened in my life. The only other time I've had more than one, me. And it was interesting because we had a PI announcement, and who's ever making an announcement would never say, well, Ken, please call the following number. They'd always use our last name because they knew there are 3 of us in the class or in the building. All right, let's get going. How do we do this? Well, there's 1 aluminum on this side, 1 on that. Ooh, it's balanced. But here I have 2 chlorine, and here I have 3. There's no whole number I can multiply 2 times to get the 3. There's no whole number I can multiply 3 times to get to 2. And what do we have? We have an even odd case. Hopefully you know your even and odd numbers. And how do we get the same on each side? Well, what number are they both? Can they both divide into? That gives a whole number. Well, the easiest way is 2 times 3 is 6. How do I get 6 chlorine on this side? I multiply that by 3. How do I get 6 chlorine on this side? I multiply 3 times what? 2 to get 6 chlorine. Well, now I have on this side 2 aluminum. How do I get 2 aluminum on this side? Change the coefficient. Remember, you can't change the subscript. And now I have 2 aluminum. And I'll check, is this now balanced? 2 aluminum, 2 aluminum, 6 chlorine, 6 chlorine. Yay, it's balanced. And what this tells me is I take 2 aluminum atoms reacted with 3 chlorine molecules to make 2 molecules of aluminum chloride. And that's balancing chemical equation. Remember my 2 pro tips, that's another way of saying it. Dr. White's a pro at this. I should be by now. Use hydrogen, do hydrogen, oxygen atoms last, and use the even odd procedure, or I call it a trick, to solve even odd. And that's how you balance a chemical equation. Now, question you should always ask in my class is, why am I learning this? Well, the obvious answer is you want to get a good grade in my class so you can get into a school, because they not, or you can get into a program like nursing, because they say you've got to have general chemistry and a good grade. But why learn this stuff? Why learn how to balance chemical equations? What's so important about that? Well, let's find out. And that's the chemical equation and the mole concept. And what I'm about to tell you is probably one of the most important concepts to me personally in all of chemistry. Yes, one of the most important concepts. And that concept is the coefficients in a balanced chemical equation give the numerical relationship among formula units consumed or produced. A better way of saying it, the coefficients in an equation, balanced chemical equation, are fixed molar ratios between substances consumed, what you're starting with, the reactants, and produced in a chemical equation. Pro tip, well, I already told you this. I've already talked about conservation of mass. So once again, the coefficients in a balanced chemical equation give the numerical relationship among the formula units consumed, but a better way is give the fixed molar ratios between substances consumed, reactants, and the products, this should be and produced in a chemical equation. So what does this mean? Good question. Thank you, Dr. White. You're welcome. I didn't know I'd talk to myself rarely. All right, let's go back and look at this chemical reaction. When I balance it, 4 hydrogen, 2 oxygen, 2 oxygen, it's balanced. Now that it's balanced, let's look at the coefficient. And when there's no number, it's the number 1. And what this tells me is 2 moles, and now it's really important, 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. I know of nothing more important in all of chemistry to me personally, and I'll explain why after we do some problems. So the coefficients, and when there's no coefficient, like here, it's the number 1. The coefficients of a balanced chemical equation tell you the molar relationships between the reactants and the product. And what this tells me is 2 moles of hydrogen make 1 mole, we react with 1 mole of oxygen to make 2 moles of water. Now, the other thing this tells me, for every 2 moles of hydrogen, I make 2 moles of water. For every 1 mole of oxygen, I make 2 moles of water. And that's the molar relationship. And if we were in a classroom, you'd be watching me write this on the board. All right, everybody see on the whiteboard the 5 points, how many moles? Thumbs up, people. Uh-oh, let me check. All right, thank you, Gianna. All right, let's look at this problem. First thing I'm going to do is find out what, one other thing you will be given. And sometimes I'll write hints, but you need to be given a balanced chemical equation. All right, so what are we being asked to find? How many moles of water? What are we given? Well, right here, we have 5.167 moles of O2. We're also given an excess of hydrogen gas, H2. What does that mean? That means you have all the hydrogen gas you need to react with however much oxygen to make the product, in this case, water. So whenever you see excess of something, what that really means is you can ignore it in the problem. I'll say that again. Whenever you see excess of something, what does that mean? You can ignore it. So once we've read the problem, we have this to work with and the balanced chemical equation. So now, guess what? The only number I have to work with initially is this. If I had some ratio, what units do I want my answer to be in? Right there. Let me move our pictures over here, actually mine and your names. And we have moles of water. And how do we proceed? Yep, you know it's coming. It's time to use your good buddy, your good friend, unit analysis. I get to be a wild and crazy guy on YouTube. And now, using your good buddy, your good friend, unit analysis, whatever we're trying to get to goes on top. Whatever we're trying to get rid of, goes underneath. Let me say that again. Whatever we're trying to get to, the units go on top. Whatever we're trying to get rid of, the units go underneath. So now I'll write those units in. I'm trying to get the moles of water. I want to get rid of moles of oxygen. And where do I get these numbers? You look at the balanced chemical equation. And notice 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. So for every 1 mole of oxygen, how many moles of water do I make? 2. I'll go through this again because there's nothing more important. In fact, I'll do it in a red. Where do we get these relationships? We look at the balanced chemical equation, and the coefficients give us molar ratios. And when there's no number, that's the number 1, is assumed, not assumed, that's what it is. So what this really tells me is for every 1 mole of oxygen, I make 2 moles of water. And that's where I get these numbers. Now, these are exact numbers. So remember that when we were figuring out how many significant figures your answer should be. Now, before I move any further, I'll check my units. And here I have moles of oxygen divided by moles of oxygen. Remember, anything divided by itself cancels out because it's equal to number 1. Therefore, this is gone. Now I'm left with moles of water. Yay, that's what I'm trying to get to. So now I can pick up my calculator, turn it on, clear it. I take 5.167, multiply it by 2, divided by 1, and my calculator gives me this number. Now, when I look at this, it's a multiplication division, and you get the same number of significant figures in your answer as the number with the lowest significant figures. Well, this number, 5.167, 1, 2, 3, 4, is 4 significant figures. However, the 2 and the 1, I'm going to erase that because that looks like a negative. Hold on. The 2 and the 1 are exact numbers. So they play no role in how many significant figures your answer should have. And therefore, if we look at this, we have 4 significant figures. So I'm going to give you 4 times 2, 8 seconds to round that off to 4 significant figures. Go. Time's up. They gave you more than 8 seconds. Keep the 1, keep the 0, keep the 3, keep the 3. That's my 4 significant figures. Use the number 4, that worked out nice, to round off. Is that 4 or less? Yes, I'm going to drop that. And the correct answer is 1.033 times 10 to the first power moles of water. And you could also have written it 10.33 if you don't use scientific notation, moles of water. And because Dr. White knows the scientific notation and going back and forth, either one of these would be the correct answer. Now, again, where did we get these ratios? From the coefficients of a balanced chemical equation tell us molar ratios. And this, for this balanced chemical equation, for every 2 moles of hydrogen that I react with 1 mole of oxygen, I make 2 moles of water. All right, let's try this again. I'll do this one, then Wednesday, I'll let you try some too. All right, how many moles of chlorine gas, Cl2, must you react with an excess? And I'm thinking the wrong reactions now. Sorry about that. There's another reaction I could have also used chlorine with an excess of sodium to make 8.14 moles of sodium chloride. So what are we being asked to find out? How many moles of chlorine? What are we given? Well, we're going to use an excess of sodium. As soon as you see the word excess, you can ignore sodium, and I will. But we're trying to make 8.14 moles of sodium chloride. So what do? Well, I'm going to rewrite this so you can see it better. This you'll always be given in one of these type of problems. You'll always be given the balanced chemical equation. When I was an undergrad, you'd have to balance it first. I won't do that to you. That's cruel, unusual punishment. All right, so the only number we have to start with is this. So I'll start that. If I had a ratio, what do I want the units of my answer to be? Moles of chlorine. And now use my good buddy, my good friend, unit analysis. And how do I do that? Whatever I'm trying to get to, I'll put the units on top of this ratio. Whatever I'm trying to get rid of, I put those units underneath. and I'll write them, which I'm doing right now. And where do I get these ratios? From the balanced chemical equation. That tells me molar ratios. Now, sodium I'm going to ignore. When there's no number in front of a molecule, that's the number 1. And that tells me 1 mole of chlorine makes 2 moles of sodium chloride. And that's how I get these numbers. Remember, the coefficient of a balanced chemical equation tells you molar ratios. And for this reaction, 2 moles of sodium react with 1 mole of chlorine gas, Cl2, to make 2 moles, and that's what that 2 tells us, of sodium chloride. And I can put those in this ratio. Now, before I pick up my calculator, notice moles sodium chloride divided by moles of sodium chloride cancel out, because anything divided by itself is the number 1, meaning it's gone. I'm left with moles of chlorine, which is what I'm trying to get. So now I can pick up my calculator, turn it on, clear it. I take 8.14, multiply times 1, divide by 2. And my calculator gives me this number. And notice, for multiplication division, you get the same number of significant figures in your answer as the number that has the fewest significant figures that you're multiplying and dividing. This says 3 significant figures. You should be able to figure that out. But the 1 and the 2 are exact numbers because they come from the molar ratios, which are exact numbers. They play no role in there. So this is 3. The answer has to be, oh, look, it is 3 significant figures for my calculator, and that's how you do it. Speaking about that's how you do it, I'm out of time. Boy, time flies when you're having fun with balanced chemical equations and moles. It really does. Now, remember, tomorrow I'll be going through practice problem 10, chapter 10, part 2. Make sure you try it before I do. Then we'll do the lab, which is already posted in Blackboard for you to see. I like those special effects. See, Dr. White's getting goofy now. But anyways, I'm done. Don't forget, my new office hours are now Tuesday and Wednesday from 6 p.m. to 7 p.m., which you can all 7:15 p.m., which you can always email me. And with that, I'll use the special log off I always use, Gehen gesund, which is Yiddish meaning go in health. That's something my grandmother always used to say to me, my sisters, and my parents when we'd leave after visiting her and my grandfather. And so I'll do the same. Gehen gesund. Goodbye. Stole that from Granny to Beverly Hillbillies. Bye now.